We'll develop the concept of difference quotient from the basic definition of gradients in this particular video. I hope that will help you for understanding calculus. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this particular video, we'll understand what is difference quotient, the basic concept, and how do we derive it from the gradient definition. This forms the base for calculus. So we'll help you understand the concept with a very beautiful example. Let the displacement in meters that a toy car can travel after x minutes is given by d of x equals to 3x squared for x greater than equal to 0 and less than equal to 6. Graph of dx is given to you, right? So we have taken a function which shows displacement of a toy car with time represented by x as the independent variable for the first 6 minutes. You get the idea. It's parabolic in nature, non-linear, increasing as shown here in the graph. Now the questions related are: 1. Identify domain and range of d of x. Question 2. Evaluate d of t and d of phi. Interpret their meaning. Plot them at point A and B respectively on the graph. Find gradient of the chord AB. Simplify the difference quotient expression. This is called difference quotient expression, d of x plus h minus d of x over h for different values for difference quotient of d of x. Question 5 is: evaluate difference quotient for x equals to 2 and h equals to 3. Interpret your result. Represent your result on the graph. So it's a communication based question where we'll try to understand the basic concept and how it relates to the gradient. I'd like you to pause the video, answer the question, and then look into my suggestions. So let's begin with domain and range of the given function. So we are given the function as d of x equals to 3x squared. So what is the domain range of this? Well, we are given that x changes from 0 to 6. So we know the domain very clearly. It is already given to us. So we can write down that the function is d of x equals to 3x squared, and its domain is the values which independent variable x can take is x belongs to real numbers where x is between 0 to 6, correct? So we have seen this graph here, it is increasing, correct? Always increasing. So if I find the values at 0 and the value at 6, I will know the range. So to find the range, we'll see what is the value when x is equal to 0. In that case, we get 3 times 0 squared, which is 0. And let's figure out what is the value of displacement when x is 6. So it is 3 times 6 whole squared, which is 72, right? 6 squared is 36. So 36 times 3, right? Not 2. So let me rewrite this as 3 times 36. And that is going to give us a value, which is 3 times 6 is 18, 808, right? So this point here is basically 6108. So as you can see here, range basically is all values of y between 0 to 108, right? Is that clear to you? So that is how we can find domain and range of the given function. So this is in function notation. I hope this concept is very clear. Now it is also very important to label your diagram. So in this, we have x, the independent variable along the x-axis, and displacement, which is d of x, is along the y-axis, whose range, which we are trying to find, y, right? I should have written d of x here. You get the idea, right? And the units are that x is given in minutes. So this is time in minutes, basically. And the displacement is given to us in meters. So this is given to us in meters. So that is also important to write down on the graph itself. You get the idea. So it is displacement with time, right? So it is, you could mention that this represents displacement versus time graph. Perfect. In a restricted domain, 0 to 6 minutes. Perfect. So now we have labeled the diagram, which we see is a non-linear in nature, but increasing all the time. That means the object is moving only in one direction. Perfect. Now let's move forward and answer the next question. I hope you have understood this particular function very clearly. Now moving forward, part 2 is evaluate d of 2 and d of 5. That basically means we have to plug in the value just as we found range by plugging in 0 and 6. So now we can find what is the value of the function when x is 2. So that means we'll substitute 2 for x, right? So 3 times 2 squared, which is 3 times 4, and is equals to 12. As far as the other point is concerned, that is at 5, x value. So 5 squared is 25, and the 3 times 25 will be 75. So we got these 2 points, we evaluated them, d2 and d5, interpret their meaning. So basically d of 2 means the y value when x is 2, right? So d of 2 is the y value of x2, and we need to plot them at point A and B respectively. So this is d of 2. So we can say this is point A for us, right? And at 2, the value here is 12. You get the idea. As far as the other point is concerned, which is at 5, this is our point B. And at 5, the value d of 5 is 75. Correct? So when I say interpret their meaning, so interpret their meaning means what? So we have found the value, correct? D of 2 is 12, D of 5 is 75. So part B will be D of 2 represents, I can write both D of 2 and D of 5 represent y value or independent variable, dependent variable value at x equals to 2 and x equals to 5 respectively. Do you understand? So that is how we are interpreting its meaning, correct? And then of course we need to plot them as points A and B respectively on the graph. So we did so. Perfect. You get the idea, right? So that is how we will completely answer part 2 of this particular question. Clear? Now, in case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are right there on top of their class getting awards and scholarships, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student, Akshat, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let's move on and answer other three questions one by one. Question number 3 here is find gradient of the chord AB. So we just now found the coordinate points for A and B respectively, right? So we found that the point A was at 212. So let me write down the coordinate point of A. So let's write down as A, and this point here is at 212, right? And at 5, we got the point B. Let me write here. And at 5, the value was 75, right? 525 times 3. So these are the coordinate points of A and B. Now the question is, find gradient of the chord AB. So chord AB means we have to connect these 2 points, right? So when you connect them with a straight line, assume this is a straight line, okay? So this becomes the chord, right? So that is the chord AB. So gradient, so what is the gradient? So you can find the gradient, which is also called slope, as y2 minus y1 over x2 minus x1. Clear? So in this particular case, we can calculate the gradient. Since we know the 2 points, for A, the point is at 2, we have 12, and for B, at 5, the y value is 75, correct? So gradient or slope m is equals to y2 minus y1, which is 75 minus 12 over 5 minus 2, correct? So you get what? So take away, we get 3 here, and 7 take away, this is 63, and we have 3, so which is 21. So the gradient is 21, correct? So that gives you the gradient. Now another important question here is that once you find the gradient, what does it represent? So that's a communication question for you. Find gradient we are asking for chord AB. Now let's look into interpretation. So how will you interpret the gradient of the chord AB? That is the question for you. What does this really represent in the given situation? The given situation is, let the displacement in meters that a toy car travels after x minutes be given by this function. So the gradient of the function is change in displacement, right? So since it is on an interval, so it is average rate of change. So it is average rate of change, average rate of change of displacement, right? So that means what? Average rate of change of displacement means average velocity during this interval of time, which is from 2 to 5 minutes. You get the idea. So which really means average velocity, right? Average velocity during this interval of time, which is from 2 to 5. You get the idea. So during this journey of this toy car, from 2 minutes to 5 minutes, the average speed or average velocity was 21 meters per second, right? So average velocity was 21 meters per second. Is that clear to you? That is how we are going to interpret the gradient of this chord AB. Very, very important concept, right? So what happened basically is that we selected 2 points on the curve which represents the position or the displacement of a toy car with time. And it can be interpreted as what? It can be interpreted as an average velocity of the toy car during the interval when the time was from 2 to 5 minutes. Perfect. So that is what it represents. So now let's move forward and answer the next question. So we are just moving forward step by step, understanding how do we define the velocity as such. That was average velocity, right? Instantaneous velocity or slope of tangent, right? So here we also see that the chord is basically gradient of the chord means slope of secant, right? Let me write down here slope of secant. So this slope of secant represents average velocity. Perfect. Now, question 4 is simplify dx plus h minus d of x over h for difference quotient of d of x. Now, this is a formula which is popularly called as a display difference quotient formula, right? So it is basically y2 minus y1 over x2 minus x1. So the concept here is that if I take 2 points which are, let us say we take a point here which is at x, right? And we take another point here which is at x plus h, right? So in that case, the y value will be f of x, and here the y value will be what? F of x plus h, correct? So now you can clearly see that y2 minus y1 is this. So this is delta y. Do you see that? Change in. And that one is delta x. So this delta y over delta x gives you the gradient. You get the idea, which is given by this difference quotient formula. Perfect. So I hope you got the understanding of this. Also with respect to the graph, x and x plus h means a point which is h unit away. You get the idea, right? So when I say we need to find d of x plus h minus d of x, right, over h, this is what we need to figure out. Now what is d of x is 3x square, right? So x plus h will be 3 times x plus h whole square. You get the idea? Minus d of x is 3x square. Correct? Because that is the function given to us over h. So we can actually expand this. We get 3 times x square plus 2xh plus h square, right? Minus 3x square over h. Clear? Now let's try to simplify this. When you open the bracket, 3x square and 3x square cancel, right? So let's first write down. We get 3x square plus 6xh plus we have 3h square minus 3x square, right, over h. Now here you can very clearly see that 3x square cancel, and what remains is 6xh plus 3h square over h. Now h is common, you can factor this out. So we get 6x, you can also factor 6, but I'm not doing so. I'm just cancelling h for now. So 6x plus 3h, right, over h. So now we can actually cancel h. So what do you get? You get your result, which is 6x plus 3h. You get the idea, right? So in this particular case, we get 6x plus 3h as the simplified form of d of x plus h minus dx over h, right? So that is the difference quotient thing which we just got. So I hope this simplification is absolutely clear. Write down the function x plus h means replace x with x plus h, right? And then do the needful as shown here. So it's very important to note that h will cancel, and so you're left with 6h plus 3h as your answer. So that is the result. Is that clear to you? Now let's look into the last part of this question, which says evaluate the difference quotient for x equals to 2 and h equals to 3. Interpret your result, represent your result on the graph. A very important part of our learning, right? So what we got here is that the difference quotient was 6x plus 3h, right? So we can write down the difference quotient, which is equal to, let me write it completely, that we got d of x plus h minus d of x over h as equal to 6x plus 3h. So that is what we got. Now the question number 5 is that you need to figure out, evaluate difference quotient for x equals to 2 and h equals to 3. So if I substitute, what do I get? I get 6 times 2 plus 3 times 3, right? And that is equal to 6 times 2 is 12 plus 9, and that is equal to 21, right? So we got 21 as the result of difference quotient. Now it says interpret your result, represent your result on the graph. So we had dx plus h, x is 2. That means at 2 we are looking at a point, right? So that is 1 point. And h is 3. So what is 2 plus 3, right? So 2 plus 3 is what? 2 plus 3 is 5, right? So x is 5. So that means we are looking at this particular point at 5, right? So, and that value was the y value. This is what we are looking at, right? So h units away. So this is the h units away, right? So from here to here, x plus h, correct? So 2 and 5. And so basically, we wrote here d of 5 minus d of 2, right? Over 5 minus 2. Do you see that? H value of 3, right? 5 minus 2. And we got this result as 21, right? So what does it represent? Can you now tell me? Well, you will remember that earlier we got the gradient and evaluated the same thing. And there we got this as 21. Do you see that? So 21 was the gradient of these 2 points, right? Of the chord AB. And what does that represent? It represents the average velocity, correct? The slope of the secant line, right? So we have got our result here, and we are saying that it represents what? So if I join these 2 points, right? So this is point A for us, and this is point B for us, right? So 21 is basically 21 meters per minute, because we are given this in time minutes, right? Meters per minute. So it represents the average rate of change, correct? Or slope of secant. So it represents 1. Let me write down slope of secant. Or it could say average velocity in this case from A to B, correct? So that is what it represents, right? So with difference quotient, we find average rate of change. So in general, we say it is average rate of change between any 2 points. You get the idea. Any 2 distinct points. Perfect. So in this particular example, we have understood how do we relate a gradient with difference quotient, right? So gradient is the slope between any 2 points, and it really represented by difference quotient form, which is dx plus h minus dx over h. And once you calculate for any given value of h, then we get the slope of the secant line, correct? Now the thing is, what happens when h is reduced? So in the next video, we are going to see what happens. So next video, what will you learn is what happens when h is approaching 0. That means this point comes closer and closer, right? So when this point moves closer and closer, what really happens? So then this secant becomes a tangent, and that is what we are going to learn in the next video, where this can then represent a derivative, right? So that will be our introduction to derivative. We'll wait for the next video for the complete discussion on the same. I hope with this the concept of gradient and difference quotient form is absolutely clear. Feel free to write your comments and share your views. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.